And so now we can try something funny here, like say the doctor and machine learning. The humans are being controlled by a virus, but the doctor has been experimenting with a new kind of intelligence, machine learning, that he hopes will be able to break the hold of the virus. Okay, so it's generating. Now let's try some more. Hey, what is going on everybody, it's Ivan here, and this is going to be a really interesting and really practical video about fine-tuning one of the most exciting ML models out there, which is OpenAI's GPT-3. And the funniest part about the video is that for dataset we'll use episode synopses from one of my favorite TV shows of all time, Doctor Who. This way will practically be fine-tuning GPT-3 to come up with new sci-fi TV show ideas. If you have a problem that you want to use fine-tuning for, we'll start off by discussing if GPT-3 is going to be right for your task. Then we'll talk about data preparation, jump into the actual fine-tuning, and then explore the ways in which we can test the model's predictions. So, and if you're excited about this video, smash that like button and consider subscribing to our channel, and if you have any questions, as always, drop them in the comment section down below and I'll be happy to answer you. And so I'd like to start off by talking about like a couple doubts that I've had and like misconceptions maybe that I've had about fine-tuning GPT-3, in the hopes that like if you're, you know, sort of like doubting whether you should actually try it, whether that'll be like useful for your task, that we can kind of clear up some of those doubts and that you can have like a clearer idea as to whether like, GPT-3 is going to be suitable for your task. And if you watch Doctor Who, you know that it's like a really jargon-heavy show with like different sci-fi futuristic tech and like aliens and stuff. And I was really surprised how GPT-3 picked up like on all the different like jargons from the show, because if you watch Doctor Who, you know that like there are different like aliens and like sci-fi tech and all that stuff. But it also picked up on things like British spellings, which is like really surprising because again, like just a couple hundred data points. So you don't really need like a crazy large data set to fine-tune GPT-3 model, is I guess what I'm trying to say here. And so the second thing that I found surprising is that for all the fine-tunes that I did through OpenAI's API, they did not cost me more than $1. In fact, like most of the fine-tunes that I did, which produced amazing results, costed like 60 cents or like 70 cents or like around that amount. And it's obviously really important to note here that you should go to OpenAI for the most relevant like pricing information, that it's gonna vary depending on the size of the model you're using and the data and for how long you're training. But that's just me trying to say that like for this task to get like this results, a fine-tune costed like 70 cents. So that is to say, check in with the OpenAI API for like the relevant pricing info. But if you have like a certain problem that you want to apply fine-tuning GPT-3 for, it might as well be really affordable. And so the third kind of like doubt that I jumped into fine-tuning GPT-3 with was, I was thinking like, what if training takes like days or like weeks or something like that? I was hoping that, but like I wasn't sure. And I was also like pleasantly surprised here because like again, at least in the context of this task, like in my experience of running like tens of fine-tunes on this data, is that not for one of them training took longer than like 15 minutes. Like most of them were like under 15 minutes. In fact, like I don't remember like a single one that was like longer than that. So and of course, like needless to say that like OpenAI, like you're uploading your data to OpenAI API to do the training, so like it doesn't matter what kind of hardware you have, and it just trains like really quickly. So I was like pleasantly surprised with that. So hopefully talking about the size of the dataset that I used, the pricing, and the training time kind of helps you decide if you want to try GPT-3. And so a thing that I wanted to note really quickly is that I wrote like a really detailed like guide about this whole process that I'll link to in the video description. So all that I say is like feel free to, as I'll be diving into more of the practical stuff right now, to kind of lay back and just like enjoy the video. And then if you want to like replicate some of the steps, you can like refer to that written guide and just like follow that for some of the steps here. But regardless of that, let's jump into the video and let me show you kind of how my experiments with GPT-3 went. So in case you haven't heard about it, OpenAI, which is like one of the largest, like most impactful AI labs out there, has collaborated with Weights and Biases, which is a really powerful MLOps platform. The result of the collaboration is that now with just one line of OpenAI Python client code, you can log all of your fine-tunes and all of your experiments to Weights and Biases. And it's really powerful because it lets us leverage all of the Weights and Biases infrastructure of being a single system of record for your ML experiments, now applied to your OpenAI fine-tunes. But let's actually see how that and many other things look like in the code. So right now we're looking at a Google Colab notebook, which I'll link to also in the video description. And the first thing we need to do is to paste our OpenAI API key, which we can get by going into our username, view API keys, and here we can copy the API key and paste it here. Now what this warning is saying here is that weights and biases by default is going to log the source code, aka like this Jupyter notebook, and if this cell contains your API key, then it's also going to get logged. It might be a problem if you make your weights and biases project public and other people can see it, and you don't want them to see your API key probably. So this warning says that you might just like delete your API key like that and clear the output of the cell, and it's not going to get logged. But personally, I'm going to burn this API key after the video, so like I don't really care. So I'll just keep it here. So what I'm doing next is I'm initializing a new weights and biases project. At this point, it may prompt you to log into your existing weights and biases account by pasting an API key or quickly creating a new one. And so having done that, now I'm leveraging W&B Artifacts, which is a tool for dataset and model versioning, to pull the dataset from that I have stored right here on W&B. Right here, it's just like a .csv file, which we'll visualize in a second, which weighs just like 117 kilobytes. And so by running the cell, I'm essentially just like downloading that from the W&B cloud to Google Colab, where we can use it for training. So having done that, we can see the artifacts folder appearing, which has our dataset file. And so something that's worth noting here is that that's the exact stage in the training process in this notebook where you should like add your own data if you want to. So for example, I'm here using like artifacts to download like this .csv file, but if you want to use your own data, you can either use like Google Colab and just upload files with Colab, or you can also log it as a W&B artifact and then just like pull it from the web so you don't have to like download it all the time. But that's the exact time when you can plug in your own data set so that like you can run through the whole process and get the fine-tuning results with your own data. But if you don't want to, like, just feel free to follow along with this fun data set, because like, you know, it's Doctor Who episode Synopses, like it's also really fun to work around and to play with. And so now in the next stage, I'm shuffling the data set, and I'm also doing something really interesting, which is that I'm logging it as a W&B table. And so W&B Tables is a tool for interactively exploring tabular data. And we can click on this link right here to open the run page, which now contains a W&B table to which we have logged our data set. So here we can kind of click around and look at the prompts, like say that's the name of an episode, and that's like, it's like real completion, like it's real synopsis. We can like, I don't know, resize the table, and just like kind of like, you know, just like explore the data in this way. But we can also use some of the more advanced functionality of W&B tables and use like some string apps to like explore the data set a bit more. Like let's say, for example, we want to look for a word Dalek, which is one of the most like notorious Doctor Who monsters, and it's definitely a fun one to look in our data. So like let's say we want to find all of the completions, like all of the real episode synopses which have the word Dalek in them. And so here's how we can do it. I'll insert a new column on the left, and we'll say that that column will be row completion, which contains the episode synopses that lower to make all of the tags that are lowercase. That contains Dalek, also in lowercase. We'll make the panel be Boolean, and yep. And now we can group by this column, and so now we've grouped by this column, and we can see all the episodes that don't have the word Dalek in them, like say, you know, 283 of them, and we can see the 21 episode synopses which do have the word Dalek in them, like here, Daleks, Doctor, Dalek City, Daleks. Yep. And so that's kind of like a funny example of us looking for a sci-fi alien race in our dataset. But you can imagine if your dataset is like some customer service reviews, like you may want to look for the entries that contain the words like say danger, for example, so that like you can handle them like in some more specific way, like in your fine-tuning or whatnot. So like it's a really useful tool. But let's actually try doing something else as well. So let's now ungroup by this column and remove it. I also want to show you how we can use some of that W&B tables magic now to find, say, the longest or like the shortest completions, the longest or the shortest like episode synopsis. So I'll go and I'll insert again a new column on the left, and we'll say that this column will be row completion.length, which will give us the length of characters. And now I can just like sort it, saying descending order, and like this will find us like the longest episode like synopsis, right? The longest like episode synopsis in our data set. And maybe now also let's try sorting it in the ascending order. And yeah, I mean, I sort of saw it coming, obviously, but here in the data set, you can see that like there's a number of episodes, which, by the way, that totally like flew past me the first time that I trained this model. So here we can see a number of episodes, which have coming soon as their episode synopsis. So apparently on the website from where I got the episodes and their synopsis, some of them were titled as coming soon. And I actually didn't notice that at all at first, but then I was kind of surprised that when I was like, playing around with the models that I trained, that some of them would just say like coming soon out of nowhere. And like doing this type of dataset exploration can give us like a pretty nice clue as to why something like that may end up happening. Now that said, the model still produced great results, but there was like that coming soon anomaly which would show up now and then. And doing this type of data exploration can be something that, you know, can help you like catch these little irregularities in your data set so that you can have the best data to train the best possible models, you know. So now let's jump back into code and let's use OpenAI's Python client tool to preprocess our data set. So the use case of fine-tuning GPT-3 that we're going for is called conditional generation, where we have like a specific prompt, aka like a name of an episode, and we expect GPT-3 to fill in the actual like synopsis and the contents of an episode. So for it to have like an easier time doing that, the preprocessing will allow us to add like a couple suffixes and a couple like little arrow things, which I'll show you like in a moment. But using the like OpenAI tool is like actually really simple. So you just click on it and you pass in the path to your dataset file, and then it kind of asks you what type of preprocessing you want to apply to your dataset. So in our case, we're gonna apply all of them. So I'll say add a suffix separator, like, you know, this arrow thing. I'll say yes. Add a suffix ending, and I'll say yes. White space character to the beginning of the completion, yes. And data will be written to a new JSON-L file, yes. Cool. So let it finish doing that. We can kind of see what it's done. We'll have this new file appear, and here we kind of see what it is. So like it took the name of an episode that added like this error thingy, and which will help the model essentially to have like an easier time training and an easier time, most important, like distinguishing what is a prompt. Like say a prompt is a thing that's followed by like an error symbol, and like what is a completion, you know, like it's a thing, you know, like after an error symbol with a white space in front of it that always ends with this like end character. And it's also really important to remember the type of preprocessing that you apply to your data set, because like once you'll be performing inference, you'll kind of also need to specify some of this stuff there. So here we're just putting our data into training and validation. And now we're actually this close to starting fine-tuning. So here we get to define the hyperparameters. So these three models, Ada, Babbage, and Curie, are currently the ones that are available for fine-tuning, and we can check out the OpenAI docs to kind of learn more about like what are they best used for. Like say that Ada would be like a lighter model than Curie, and like all that stuff. And I'll go with these values for the other hyperparameters. So the cool thing is that, as we'll see in a couple of minutes, you can like experiment with different hyperparameters and then log experiments to weights and biases and like see which ones work better. And that's kind of how you can like explore which hyperparameters like work best for your specific application. And so now we're actually ready to jump into fine-tuning. So here we call OpenAI API fine-tunes.create, pass in our training and validation data and all of our hyperparameters. And then pretty much just run this cell of code to start the fine-tuning. Here I'll press enter to choose to re-upload the data. And as you can see, the cost for this fine-tuning will just be 28 cents. And like, I'm not an expert in economics, but sounds like a pretty good bang for the buck if you ask me. And now we just kind of gotta like wait a little, you know? So as you can see, our fine-tune now went through 4 epochs. And if we actually time it, we can see that it took like from 17 minutes to 21 minutes, which is like what? Like 4.5 minutes? 4 minutes and 40 seconds? So it's like apparently this numbers and this numbers are even like lower than what I've talked about in the like doubts section of the video, which is a good thing, obviously. And so as we've talked about it before, now we'll run just one line of OpenAI code to sync all of our fine-tuned jobs to weights and biases. In this cell, we can explore the usage of this command, and in the next one, we'll actually run it. So as you can see here, it goes like OpenAI, 1DB, sync, and here I specify the weights and biases project, which I would like to log the fine-tuned jobs to. I'll select the one to which we're also logging before the W&B Tables and stuff, which is GPT-3 for generating Doctor Who synopses. And now let's run this cell. And so now OpenAI has finished syncing our fine-tuned jobs data to weights and biases, and this is really, as you'll see in a couple of moments, will help us take to the next level how we're analyzing our GPT-3 fine-tuning experiments. Let's click on this link to open our project. So this is a weights and biases project dashboard. On the left we have our runs, which is like our instances of us training models or logging artifacts or doing like other things. And on the right we have like the data associated with them. So for example, here we can see like the tables that we've logged before, but the new thing that we want to look at here are the training metrics. So maybe let's drag this panel somewhere to the top maybe. And so now as you can see, it's comparing the training and the validation metrics of all the different fine-tuned jobs that I've done. So as you can see on the left, all of the runs that are named like Floral, Butterfly, or Dauntless Wood, which is like a standard naming scheme and weights and biases for new runs, are the runs that we log with like W&B tables and like model predictions. But all the runs that are named like FT and then like a bunch of words and letters are the runs that are corresponding to like specific fine-tuned jobs. However, as you can see, like it's fairly difficult to look like at say a run that's named like FG, a bunch of stuff, and like be able to reasonably say which model that run was trained on or like what it even is. And here we can take advantage of something called runs table right here, and the fact that like along with all the like training metrics, what's also getting logged are all the hyperparameters and metadata for a specific fine-tuned job. So for example, let's take this like FG guy here. For example, I can go and pin say the hyperparameter with the name of the model, which contains, let's make it a little bit larger. Oh no, not the created one. Let's unpin this column. I want to do this one, fine-tuned model, which has the name of the model, right? So let's pin it. It has the name of the model and when it finished fine-tuning. Okay, that's really good. That gives us a lot of useful information. First of all, it's like the name of the model when it was fine-tuned. So now let's maybe get the data that it was trained on. So this guy here, pin column, yep, training file, Doctor Who train. And let's say as we're like comparing our models, we want to keep like a closer watch, say on the number of epochs that a specific fine-tuned job was trained for. So let's pin this column also. Maybe make it smaller. And so as we go back into the project page now, we can see that like for each of the fine-tuned job runs, we can now see the name of the model that it was trained on and like when, which it's basically the model name. It's going to be useful for us also quite soon. We can see the dataset that it was trained on and the number of epochs. And we can make it like showcase any of the many hyperparameters here that, you know, me or you may find useful. This one seems like a little bit too large, so maybe I just folded enough to see the name of the model, and that's kind of enough for me. Yeah, and so now that gives us a lot more data, but then there's still like a lot of really different runs selected. Maybe I don't want to look at all of them, so I'll just go and I'll say visualize none, and I'll just go and like I'll manually select all the latest one that we did, so that like none of the like say older ones that might not be relevant for the current experiments displayed here. So for example, yes, I would say like all of this one are fairly recent one that I can select. And so now we can easily compare the validation or like training losses or accuracies of the relevant models that we have selected right here. And so now I can open, for example, this chart and compare the validation losses of the different fine-tuned jobs. However, one of the best ways to actually test the performance of generative models is to look at like their actual predictions on like the actual episode, like synopsis episode ideas that they come up with. And here's how we can do that. So right now we're going to take our validation data set and log the model's predictions on all of the like episode synopsis from that validation data set, along to like the actual ground truth real episode synopsis which like actually aired on television, you know? So here we'll create an evaluation job. And so here's something really cool that I wanted to note that's happening. So in order for us to log these predictions, we need to perform inference in Python on our validation dataset. And to do that, we need to use OpenAI's like API command in Python, which needs to know the name of the model that we're going to use for this task. And here we're using like a really clever way of, we have logged all of our fine-tuned jobs data to weights and biases. Now we can refer to our project there and get the latest fine-tuned details, and from there extract the metadata, and from that metadata we can get the name of our fine-tuned model. Then do some data prep on our validation data set, and then knowing the name of to which like fine-tuned model OpenAI API actually needs to talk to get these predictions, we can run the cell, which will essentially perform the inference on our validation data. And so as you can see, since we just have like 30 validation images in our validation dataset and we've performed inference like on all of them, it didn't take really long. It took like under a minute to like compute all of those results. And now we'll go and we'll log these predictions as a W&B table again so that we can like interactively explore them. And click on this link to open the run to which our predictions table has been logged. And so voila! Now we can see a W&B table which contains the name of an episode, the target, which is like the real episode synopsis, and then what GPT-3 has generated. And so here we can click around and explore the predictions or performing all of the like string ops operations that I've shown before. We can kind of like maybe find some, let's say that this is like a shorter one. Dr. and Donna takes to the first alien world, and here's like what that's the real one, that's what the model has generated. You see the Doctor and friends arrive like on a planet, mysterious alien oud litter, known as the Thean oud. So like, it's like sometimes some of the stuff it generates, I'm like legitimately like, wow, like that sounds even cooler than the original idea. But if you haven't watched the show, it's like doing quite a good job on picking up like on all of the like jargon and all of the like show specific things. And obviously this is like a really cool way to like actually get a sense of how the model is doing. And so another really cool way to test and use like the model that we've just fine-tuned is using OpenAI's Playground. And here's how we can do it. So we go to our project page and we can use this tab right here to learn the model's name. So like that's the last fine-tuned job that we've done and that's its name. Then we go to OpenAI's Playground and here we can select the engine, and then I go here and I look for a query model which ends on 2123. Yep, so here it is. And I'll also add here as a stop sequence our word "and" that was added to our dataset while preprocessing. And so now we can try something funny here, like say the doctor and machine learning. The humans are being controlled by a virus, but the doctor has been experimenting with a new kind of intelligence, machine learning, that he hopes will be able to break the hold of the virus. Okay, so it's generating. So let's try some more. Technical college. Computer barriers to reprogram it. You'll be the next victim. Or we can try something like, I don't know, like even here I try to do some the Doctor and GPT-3. And so as you can see, there he encounters a crashed spaceship from Earth and the crew of a ghost ship, the GPT-3, who are the descendants of the humans on a lost expedition from Earth. And so as you can see, it's like actually really fun to click within this OpenAI Playground UI and actually like generate some new stuff using GPT-3. So thank you for watching this video. As I was saying, I wrote like a really detailed guide on the whole training process that I'll link to in the video description, but that guide also contains like that game of real or fake, where you get to like guess which episode was like actually real and which one was like generated. So if you want to like also try whether you'd find the real one or would like GPT-3 like fool you, you may also like enjoy reading that report for that reason. But yeah, as always, like smash the like button if you enjoyed this video and consider subscribing to our channel to see more tutorials, interviews and talks. And thank you for watching this video. I really hope you enjoyed it and found it useful.